You guys like optical illusions? Here's one you might be familiar with. It's called the Thatcher effect. Upside down, this looks like a perfectly normal photo of the Skeptic's Guide to the Universe podcast co-host Jay Novella. But if we turn it right side up, ew, right? Other optical illusions can be quite elegant. For instance, the ambiguous cylinder, rectangles and circles illusion by Kokichi Sugihara. I couldn't get clearance for the accompanying music by Yoko Sugihara, so I'm going to approximate it with my own original composition. The video shows various round cylinders reflecting in a mirror as square cylinders and vice versa in different combinations. Seems like it could not have been done without some sort of visual effects, but amazingly, it was. This is just a mirror, and everything was captured by the camera as it appears. How was it done? Well, a busy little 3D printing beaver was quick to demonstrate the basic technique, so very quick. But some questions still remain unanswered, like how was this piece done? And why are 3D printers still so terrible at the thing they're designed for? So let's figure out exactly how the illusion works and explain each object featured in the video using nothing more than state-of-the-art computer graphics. Here's a flat square. We can depict it rotating three-dimensionally in a 2D video with perspective cues. But these cues are ambiguous. You might be looking at a square straight on, or a trapezoid at an angle. In 2D, there's no way to know for sure. By using an object's shape to counteract perspective, we can secretly encode a completely different shape in the same object. The ambiguous cylinder is ambiguous because it's neither round nor square. It's halfway in between, and it can be nudged to one extreme or the other by the perspective of the angle from which it's viewed. We have to decide on this angle before we can modify the cylinder's top and bottom to make the illusion work. Let's use 45 degrees looking down, just like in the video. The mirror reflection is the same 45-degree angle from the opposite side. To make the cylinder look more round in this view, we need to flatten the top and bottom corners while stretching the side corners vertically. Coincidentally, to make it look more square from here, we need to pinch the side corners while stretching out the top and bottom. Both adjustments can be made simultaneously by distorting the edge vertically into an S-shaped curve tuned precisely for our viewing angle, but without rotating the edge surface. We also have to tweak the sharpness of the vertical corners for the focal length of our camera's lens. A kind of technical detail that some make-anything punk wouldn't know about. Okay, what? These kids, they put things up overnight and then get 3 million views and I'm sitting on my... The resulting effect is flawless, as long as we light the object softly to get rid of telltale shadows and keep the viewing angle exactly the same. Changing the camera's position, or even the lens's field of view, would cause the effect to break down. All the different shapes featured in the video are variations of the same initial object. The 6 adjacent cylinders are 6 adjacent cylinders. The 4 intersecting cylinders intersect at slightly varying heights, making it possible to hide the intersection on the square side. The 12 nested cylinders have the inner ones reversed and connected with flat bridges at appropriate angles. And the 2 disconnected cylinders are actually attached at an offset height and use a false corner piece to make it seem like they're intersecting on the square side. Together, they make up a masterful illusion worthy of the 2016 Best Illusion of the Year prize. Or is it Illusion of the Year? Correlate your neurons, Neural Correlate Society. Isn't it nice to understand something so thoroughly that you're sick of it and never want to see it again?